Hi, my name is Scott Locasio. This is a demo for CmpE207, Homework 6 for fall 2021. Okay, switch to my screen. Okay, so here is basically just to go over the assignment was to create a client that would send um, a file over to a server, and the server is going to be a concurrent server and a connectionless current server. So a concurrent server, so it's a concurrent server that uses TCP sockets, and every time it gets an exception or a connection request, it accepts it and hands that socket over, that connection over to a thread that it spawns, and that thread then performs the service that the client is looking for. And the other thing that file server does is it has a monitor, so it monitors threads and prints out some statistics on the, or not statistics, but statuses, I guess, on them. So basically, just going to print the open threads, the total number of threads, and the number of bytes. And so this is its own thread. And these variables are atomic variables, so they're not. There's no mutex that the users need to handle in their code, so I don't need to provision any mutexes and handle that. That's part of the standard. Standard library has an atomic type, and you can describe, right? I don't know if it's a type or what I'm sure it'll tell me, but yeah, I guess it's a type, and it has, so you can select integers or bools or long integers or a variety of different types that can be atomic, and basically that just pretty much does all the handling of the mutexes for you. So it still prevents the race conditions and locking, but you don't have to do any of the mutex handling, and it doesn't necessarily make anything faster or better. It operates the exact same way. So if someone's using a resource and you're trying to, if two threads are trying to write to one of these variables, whoever has it open first is going to finish their write, and then it's going to allow the next thread to perform that write. So I guess they probably overloaded the like assignment operators and things like that to include mutex access and things like that. But so using atomic variables instead of just creating a bunch of mutexes and makes it a little cleaner, I suppose. So yeah, then for the server, basically it's just going to take in some arguments. The arguments are going to be from when it's created, just the results path, what path you want to be saving these files that you're receiving to. So that's how it starts, and it creates the monitor thread and detaches that and lets that spin off. And then it goes through, make sure that you can access that directory that you want to store the results in. So it either can access it. If it can't access it, it tries to create it. And if it can't create it, then it'll fail and exit the program. Next, we just open that TCP socket, bind to it, and listen for connections. Or we set it to listen, and then we move out and we wait on exception. So yeah, I get confused with that sometimes. It's not blocking on listen, it's just allowing it to listen. And then I also put a timer on these. I put a timeout on that socket. I could have done a select statement so that it just only goes in there when there's something to. I could have done a select statement and put a timeout on the select statement, but I chose to do it this way using set sock opt. And so every 3 seconds it'll just stop listening and go out and check and see if anybody if that control C got hit and and the server needs to stop. So that way it's not just going to be totally hung up on on trying to accept, because it will block there on accept. And basically, as long as if it was a timeout, then it's just going to keep moving. If there was an error and it wasn't timeout, it'll exit. Sorry, my voice is a little raspy, I guess, for some reason today. It sounds kind of annoying on the microphone, but and if it gets an accepted request and it's valid, it'll create a new thread and pass it off to the file service handler function and give it the arguments, which is just the accepted socket, the results path that the file should be saved to, and the thread quote unquote ID, which is just the number of accepted threads there. So that's that. And once it leaves, it'll tell the monitor stop. It'll close the TCP socket and return whether it was successful or a failure. And for the handler, it just comes in here and casts that void pointer to its arg struct and then starts using them. Kind of have a not very clean way of creating the file name. I guess I could have like combined the client IP with the file name or something. That a client could have sent me the file name first, but I didn't create that kind of a protocol. I just am gonna save files as I get them, and based on like the timestamp and the thread ID, and it's gonna be a text file. So obviously there's a lot more. You can make this as sophisticated as you want to, like with different file types and everything like that too. So I just kept it there instead of going any farther, because the assignment didn't call for any more sophistication than that. But then I just try to open the file pointer, make sure that path can be opened as a write, and then as long as that happens, then it's going to go and listen for messages and go ahead and save each of those messages. Just going to keep saving them to the file until basically the client closes its socket. And once that happens, then it comes out, closes the file pointer. It's going to close the accepted socket. It's going to free all the allocated memory that I allocated for those arguments. It's going to decrement the open threads. And up here we increment the open threads, and that's that atomic variable. So we do that, and then we exit, and so that's pretty much it. And the thread monitor it sleeps instead of waiting on like a timer interrupt. That the timer interrupt is more faithful in terms of, it's every 5 seconds you're activating, but just to print the monitor stuff, I just felt like this was a kind of a simpler implementation, and it's not necessarily critical that we know it was exactly 5 seconds that the thing got printed, and it's pretty low amount of stuff that's doing every 5 seconds, so it's not going to be very far off. So that seemed fine. And then we just have processing options and then checking the directory, just trying to get into that directory that you said you wanted the results saved to. Can't, then it's going to make the directory, and if it can't do that, it's going to fail it and say not happening. Or if it failed to access it for a reason other than it was not existent. So there's the server, and all the client is doing is just getting the address of the server and the file path that you want to send, and opening that file, connecting to the server, and then it's going to keep looping through and sending, going to grab as much out of the file as they can and keep sending that over the TCP port until it's there's nothing left to grab, and then it's going to go ahead and free. I allocated some space for the character line that we're going to be using in fgets, and then so it's going to free that, print how many lines it got, close the file pointer, close the socket, and get out. So that's all we got there, and a real quick demo here. So we're in homework 6 directory, and you can see we have the file client and the file server, and then 2 text files. So I'll show you what's in those text files real quick. We just have like a little testing file that's kind of easy to visibly see whether or not something gets corrupted when it gets sent over. And then there's a Tale of Two Cities text, which is the full text of the Tale of Two Cities novel. And I just did that so I can verify that I can send a very large, a fairly large file over. It's really not that large when you consider file sizes, but so those are the 2 files we're gonna go ahead and try to send. So just go ahead and show that it can compile. So it's that G++, and we have to have the pthread flag on there. It's our file server.cpp, and that compiles just fine. And then if we start it up, oops, oh well, yeah, I removed results. So you can see right now in this directory we do not have a results directory. So when we start the server, that will be created. So and we want to do the results path, so we're just going to call it results. Okay, so it's listening. And then if we refresh this, you can see that that directory got created. There's nothing in it. So there we go. And then every 5 seconds, it's going to print that monitor information, which, there we go. That running, and then what's next? So we're going to go ahead and open up the client guy. So there's LS there as well. So you see we're in that same directory. We're gonna compile that client, make sure it compiles, it does, and then we're going to select the address as just localhost, and then we'll start out with the send1.txt. Okay, so it's going to try to send that as a test file. Okay, and it did, so 3 lines, which we did have 3 lines, and so that's good. And you can see here every time I get that, I print the file name that I saved it to. We can see that there were 2 connections total so far. We've got 900, a little over 900 bytes, so that looks okay. And then next, what we're going to go ahead and do is send over the Tale 2 Cities text. So we're going to send that over. It looks like that completed, significantly more lines, significantly more bytes, and only 1 more connection request or connection setup. So I'm going to go ahead and close this. We can take a look at the results. And so we have that first one that we sent over. That's here, and that agrees with that send text. So that's the same file here. And then we're going to go ahead and open, and I sent 2 of those over to the same. And then we sent over the Tale of 2 Cities book. You can see there's that. It's all in there. Appears to be all in there. Don't really have to read it to know. 12879 and the end. And so if we come over here and open that same Tale of 2 Cities that we sent, okay, 12879 and the end. So yeah, so that is my demo for this assignment. Okay, thank you very much. Bye.